Well, hello, this is Judy Warner, Director of Community Engagement for Altium. Thanks so much for joining us today, and I hope you're really going to enjoy this lively conversation with myself and these three gentlemen. Jeremy Waller joins us from Quantel Laser and is an EE and is a senior EE and manages a large global team of engineers. I also have Jerry Partita, who has been doing front-end engineering for circuit board shops for many, many years. And he is with Summit Interconnect Technologies. And then I also have Greg Zeraldo, who is with Advanced Assembly. And they do a lot of assembly work, but particularly around new product introduction and prototyping. So, gentlemen, welcome. I look forward to this conversation.
Good to be here, Judy.
So as a setup for this conversation we're going to be talking about, we've all heard for design for manufacturing, but at Altium we've been talking a lot about how we can move the stakeholders closer together. In our minds, the design engineer is, we call, the primary stakeholder, and fabrication, assembly, component manufacturers, we all think of as secondary stakeholders, just to be clear about our conversation. So there are obviously disconnects between these parts of bringing a circuit board from design to full realization. And so this is what we're going to talk about today. And at Altium, we like to move our tool in a direction where we're designing with manufacturing. And Altium 365 and moving some of these things into the cloud is a step we've made from our end to try to create this full transparency. And so we're going to talk about, we're all working remotely now. So what are some ways, what are the disconnects that exist? What do you need to know to work better with your supply chain? And what are some tools as we're all working remotely? What are some coping skills sort of we all come up with to work effectively during this unprecedented time? So I hope you'll enjoy this conversation. Gentlemen, why don't you first start by giving a little bit about yourselves, your background, your company, and Jeremy, I'm going to start with you.
Okay. I'm Jeremy Waller, as Judy already mentioned. I'm the Senior Electrical Engineer at Quantel Laser in Bozeman, Montana. We develop and manufacture pulsed solid-state laser systems, primarily Class 4 type solid-state laser systems for industrial, scientific, and defense-related applications. Quantel Laser is also part of a much larger laser group called Lumibird, and so we have design centers located all around the world, primarily in France, Canada, Australia, and of course the United States. And so that expands our laser division out into medical and fiber laser, laser sensing applications. So it's a pretty exciting company to work for. A little bit about me, I guess, to relate to any viewers out there. I've been doing this for 20 years. Just last week, I got my CID certification, so it's never too late. That was a good experience. So anybody that's looking for that certified interconnect designer certification through IPC, I'd recommend it. But I would describe myself as an all-around engineer, somebody that has been spending a lot of time over the last 20 years with the full concept to delivering the product. And so I'm an all-around engineer. I get to do the double E, the PCB design, the test engineer, the manufacturing engineer, or anything else in between. So I get to supervise a group of engineers at Quantel Laser doing similar functions. And also I'm a longtime Altium designer, Altium user with Altium Designer, and the Vault concept. Most recently with the Altium 365 release, we've been moved over into the cloud, and that's been an exciting experience. So with that, I'll pass it on to Greg or Jerry.
Jerry, how about you go next?
Hi, I'm Jerry Partita. I'm with Summit Interconnect. We're the second largest printed circuit board fabricator in North America, Director of Technology. I've been in the industry since 1984. First 10 years as an application engineer for Charles Test Equipment, and then Orbitech, Orbitek, Optratech, and then really my nature is an application guy at heart. I've worked in printed circuit board fabrication for 24 years now, actually 25 years, and have in the time been responsible for a department tooling over 40,000 different part numbers. We build rigid flex, high-speed digital, mil-aero, very complex boards at Summit, and I'm part of the IPC committees for various different standards. And so get involved with many of the folks that we have today, from the assembly to the design, so that we can improve the standards. Thank you.
How about you, Greg?
My name is Greg Zeraldo. I'm the Senior Director of Operations with Advanced Assembly. Been with the company for just over 3 years now. I'm a graphic designer by education. That was a lifetime ago. I started working in the EMS industry a little over 15 years ago, and I started with TTM Technologies in Littleton, Colorado, and grew with that company over to manager of manufacturing. And then since departure from there, we've been with Advanced Assembly. Advanced Assembly, we typically focus on the NPI level of aerospace, mil-aero. We do some kind of IoT programs and stuff like that, but our big focus has been more industrial and mil-aero. We just recently got our AS9100 D accreditation, so we grew out of the ISO standard and up into AS, so we're super happy about that. And just keep going, so glad to be here.
So as you see, we have an important group of folks here, and normally in our day-to-day world, we tend to get disconnected as each part of this system is highly complex. And so, as Jeremy said, we're all sort of being jacks of all trades when we're design engineers these days. So we want to talk about these disconnects next. And just so y'all know, the reason why I'm moderating this panel is I spent 25 years in technical sales and marketing, and I would work between people like Jeremy in the design engineering side or manufacturing engineers and their board fabricators and their assemblers. So, and I have all the bruises to to account for that. So I felt, I would really like to enjoy this conversation with these gentlemen. So we're going to jump right in, and we might be taking the gloves off in this boxing ring a little bit, but our purpose here really is to talk about what blind spots you might have that you don't know about, and how do we solve some of these problems. So I'm going to do a little straw poll here and ask all three of you, starting with Jeremy, what percentage of jobs that you send out to your fabricators or EMS would you say go on hold these days?
Okay, good question. These days, I'd say it's better, because with experience, you figure some of these things out. So if I was to answer that today, I'd say something around the 10% of our projects that go on hold. But if I was to rewind, 7 years or so, we started using in the development side of things, we'd start sending, rather than hand stuff our designs, which was ridiculous. So I hope nobody's doing that too often with these complex boards these days. But we shifted over and started using people like Advanced Assembly for quick turn proto shops about 8 years ago. And I have to admit, when I'd send a design to Advanced Assembly in those days, I'd cross my fingers, about 90% of the jobs would come back on hold. It was a pretty high percentage. So we've flipped things over the last few years quite a bit.
Well, you're right on the front end. Jerry, what percentage of jobs would you say go on hold once they hit your team's desk?
So it's interesting because it depends what market segment we're talking about. So a lot of our commercial customers are around 60, 70% on hold. But many times they say, just fix it and just tell me what you did. And you can proceed and you just notify them. And when we work for Mil-Aero, there is nothing we can do without them changing or approving it, which means they're changing the data. And that can run into the 80 or 90 percentile. There's been a major influx of new engineers hired, and they make a lot of errors because they're learning their skill, and then we have to point out to them. And then with the military, there's very specific compliance requirements on the finished product, in which they never designed to meet that compliance. And then we have to point out, you asked for this, we can't meet that annular ring or that epoxy fill for that aspect ratio. And so you have to go back and get documentation changed in order to get it to continue in the manufacturing process.
What would you say, Greg?
So it's interesting. So Jeremy makes a super valid point on the beginning, on the introduction to a CM, on who you're working with. And I think the point to be made there is that if you are new to a CM, there's gonna be errors, there's gonna be BOM discrepancies, there's gonna be part number discrepancies, value discrepancies on the assembly side of things. And unless that technical question, that TQ, that exception is answered by the customer, it's going to stay on hold, or the product is going to be delivered incorrectly. I would say just on average, you're looking at probably at least 75% of incoming orders go on hold within a matter of hours, just for missing documentation, missing information, a poor BOM roll-up. One of our biggest things, even prior to our AS9100 accreditation, we still work with a lot of the prototype markets of a lot of the primes. A lot of these guys carry their own inventory, so therefore they have their own inventory and part numbers that don't correlate to anything from a large distributor would. So then they send us their BOM with their numbers on it, and there's immediate flags and questions as far as, what is this? I have no idea what this is. And that's just the start of it. Fab and assembly are two completely separate animals from each other, and both in their respective rights, there is a myriad of different things that can go on hold for any reason whatsoever.
Well, before I dig into some of the reasons why these disconnects happen and these jobs go on hold, I wanted to let our audience know that we will be answering your questions in a live Q&A after this. So, be thinking about the questions you want to ask, and we'll be sure to get to as much of that as we can. And then we'll also meet you over in Discord and try to answer more questions there. So this is sort of a juicy question here, you guys, is what are the things that make these jobs go on hold? What are these pain points? I wanted to say before I let you get going on that one is Jerry mentioned something good, which is that there's a lot of younger engineers entering the market now, and they're EEs, right, that are now laying out their own boards. And some time ago, those used to be two distinct roles, but the world has sped up, and the older pure PCB designers and the EEs were two different roles. But now these young engineers that are so smart are coming out of college with an EE, but they have never maybe been inside of a manufacturer, either on the EMS side or fab side. So I think that has sort of exacerbated this problem. So that's one area that I see that, creates some pain in that area. What other areas would you guys say that create these major stumbling blocks? And I'll just let you free for all at this point.
Well, I guess I could start by, one of the reasons why things flipped for us over the last 7 or 8 years, as far as on hold, going back to what I said, cross your fingers and hope we don't get a big thing, is I used to despise the exceptions reports. We'd get a report back that says, these are all the reasons why we can't continue in your project. It'd come back like the next day. Most of the time it was supply issues. So from my perspective at that time, we would send a bill of materials out, and it would come back and we can't locate this part. We need an alternate approval here. There was a lot of that that happened. So the bill of materials was a big one, and that slowed down. It put us on hold a lot.
Greg's favorite.
Yeah, I think that's a great point. The BOM, as far as on the assembly side of the business, is critical to life. I mean, that's going to be your showstopper. That's the first thing that we're looking at when we're looking at, you know, your file package. Obviously, everything's got to be there. Your pick and place files, your BOM, you know, any schematics or anything like that. But I would say 100% of the time when there's errors found, it's usually BOM related or just the BOM itself. Either the formatting of it, like I said earlier, part callouts, reference designators, part families, value descriptions, so on and so forth. Because what happens with this is that, you know, like Jeremy said, this creates an exceptions report of just things that are not there that you're calling out to use that we can't find. We have an alternate for it, or there might be a value description. There's either a size description or a discrepancy. It's just, it just, at the end of the day, it slows it down. And when you're in, you know, the world of quick turn, when you're in the world of prototyping and NPI manufacturing, every hour counts and you're just losing time. At the end of the day, you're just, I mean, the longer it sits, the longer you're sourcing parts again, resubmitting files for approval. It's just hours, and ultimately it turns into days that the product is not back in your hand.
For us fabricators building a printed circuit board, when we receive the design, most of the jobs that go on hold is documentation. It's in the fabrication drawing, and nobody reviews what they wrote. If they add a couple of vias, they didn't update the drill chart. So we receive a data that the drill file doesn't match the drill chart. So we're wondering, is the drill out of date and the data's right? Or do we have the old drill data and the drawing is new? We have to stop because we can't assume which one is correct. And so a lot of times people just do not read through their drawing and determine if everything in the instructions is actually matching the data they have. They'll ask for an impedance, let's say on layer 1, a 5 mil trace, and we're like, there's no 5 mil traces on layer 1. So did you, if it's there, it's impedance. If it's not there, wait a minute, if there's a 4, that was supposed to be the 50 ohm. We can't guess what the intent is, so we have to stop and provide that data back. And then we go through the data and see if they're calling out different feature sizes. They call out a tooling hole plated and there's no copper anywhere. It's not connected to anything. Oh, it's probably non-plated, but it says plated on the drill chart. So there's a review, and it's time consuming. It takes time to go through and verify that everything's correct. Of the jobs that go on hold, about 70% of the jobs that go on hold is just documentation clarification. And then also, as you do military jobs, you have to look at flow down requirements, statement of works, and POs, and they start conflicting with each other. The PO says to override the flow down requirement, which is different from the print. Which one do you want? Is your last chance to make your change, because the print looked like it just got updated and the guy doing the PO doesn't know that that was flowed down, or did you put it in the PO to override everything else? And so most of the issues we get is in the documentation. And one of you guys brought up a thing, you know, we send it, we hope we don't get any feedback. Jeremy said that. And then when people said, do a DFM and just see, before we give you the order, go review it. And I always laugh at these things, because it's like, all right, this is my take on it. I want you to review my design. I'm not going to look at it, but you look at it. Take somebody with 25 or 30 years of experience only, have them review it, list everything that's a design for manufacturability issue. When I get the list back, I'm going to argue with you, could you just build it the way it is and not make any of the changes? And it's like, no, you asked me to look at this. This will affect my yield, or I can't comply to it. But can you just build it anyway? And so this is some of the fun parts when we get these DFMs. We look at from our fabrication point of view, because it was for us, for design for manufacturability. As we've gotten smarter over the years, we're looking for compliance, the end use, yields. But ultimately, when we feed back information, people are like, we've already gone through the budget for design. We don't have time to go back. the forms have set, we're going to pour cement. You're asking us to pull all the forms out and redo it. And yeah, that's it. That's why we want to do the design review. And I think that's what's exciting about Altium with the design review before the designs are completed. Is such a powerful thing, because when you get into the military world, the average cost to update just a dimensional error and to get it approved will cost $10,000 to $20,000. I saw the approval list about a month ago from a customer, and there were 40 sign-offs. And each one of those persons to do that review, sign off, roll the rev, has to put their name and put a contract for the hours they use for it. And that's how the cost goes $10,000, $20,000 just because somebody typoed a dimension.
Yeah, I've lived in that world, and everything has to be perfect, and that gets so crazy expensive. What about revision control, Jerry and Greg, I guess, do you see that issue coming up? I know I have in the past where, that comes up like, you want me to build this, but this is an older revision than the last one we built. What kind of disconnects do you come up regarding revision control?
So there's a couple. The worst one is there's a revision while we're in the middle of manufacturing, and they change something on the outer layer in the ledge, and we're like, everything that we have for our tooling is already set to the previous rev. For configuration control, if you're doing AS9100, you're supposed to have tool configuration control. So you're supposed to roll the tool to a different tool. So technically, you should cancel the order, charge them for the canceled lot where you were at, full fee, and then start over. But it's like, we're just changing the silk screen on the outer layer. We forgot the plus sign for a diode. All right, we'll just keep it. And now we have two different configurations that's running. It's one thing, it's not the other. And if there's orders that have been built and shipped, you have to go get your stock and sometimes just throw it away, because somebody will go, oh, I got 5 pieces in stock. We'll ship those. Now the diode plus sign's missing. And trying to do a revision change in midstream is dangerous. So revision control is one of the things that does happen quite frequently. And like I said, a roll rev change because we caught something. They have to roll the revision. It costs them tens of thousands of dollars, and then we have to pick up where we're at and then go and put in process. Usually, in some cases, we have to cancel the whole thing, charge to where we're at, and start over, which impacts everybody's schedule.
So, Jeremy, you do some military work and some commercial work. So you sort of dip your toes in both these areas. How do you go about with your teams, keeping that revision control in check?
Well, we have gotten pretty strict on we will never try to slide in a new paste layer or something in the middle of a revision. If we have to make changes to a document package, it's pretty much a rule at our facility, at least, to just, you have to do a whole new revision. If it's been shared with anybody, a new revision, even if it's just a tiny little plus sign in the silk, as Jerry was saying, it seems like a shame, but you have to do it. And so it kind of, in the old days, years ago, we just manually piece all these files together, take all the Gerber artwork and the BOMs and pick and place and all the things that these guys need to build this assembly. We manually piece it together in a zip file, throw it in an email, and send it away. Well, if something was wrong, Jerry comes back and says, "Hey, you're missing the pick and place file," or, well, that would be great, but you're missing the fab drawing. I'd be like, "Oh, okay. Well, I'm just gonna manually throw that in there and send you a new copy of that same revision." Look, it's a problem, because now he's got 2 copies of the same, technically the same assembly, but pretty much stopped that completely with the server-based Altium 365 arrangement. It doesn't even allow us to do that. The revision and version control on that thing's tight. If I release it to the server and then take it even further, we don't do the email and the zip file sharing anymore. We share it directly from the server. So with the send to manufacturer function, I get to send it straight to Greg, who then can share it with Jerry. And then everybody's got all the information they need. And if a change needs to be made for any reason on that design, I need to actually make that change in the design and produce a new release. I can't change it because it's in revision control. It's impossible. If I want to go in there, I guess I could delete it, but that would just break all the rules of revision control and probably cause problems with the version control. So it really helps us keep the documentation well controlled, I think, and provides a good way to share this documentation with the people that have to build it.
So from my perspective, you guys, when I used to sort of stand between you all, sort of advocating, I would say, you know, long before I joined Altium, I would say, you know, these darn EDA tools are too powerful. There needs to be some kind of feedback that says, no, dummy, stop. You know, like, don't do it. And it sounds like some of that has been plugged in that scenario. And communication is a terrible problem because, of course, email isn't efficient. It's quite manual and linear. Greg, I wanted to ask you about something you had mentioned to me before was relative to BOMs. You know, say someone like Jeremy sent you a BOM in a, you know, the sort of normal way we do things, and he made that BOM 3 weeks before you got the job. You know, by the time the BOM hits you, what does that do on your end at Advanced Assembly?
Well, it's kind of twofold. One, if nothing changes, you know, we're able to go through the DFA process. We're able to make sure that everything, you know, the assembly basically tells a story, and that story is a finished product. To kind of touch what you're saying, and then also on the rev control side of it too, is that I can't tell you how often somebody will submit a BOM, and then a day later they're like, oh, hey, just kidding. Let me send you another one. And then that'll go to Rev Dash, Rev A, Rev B, Rev C, you know, so on and so forth. And it just convolutes the whole process. You know, again, it goes back to time. Time is money. Time is product that's just in limbo somewhere. Yeah.
Yeah, I've seen that in the past where, you know, these parts go obsolete or something changes.
Oh, yeah.
The just kidding thing can happen a lot, and it's a lot more complicated. And, you know, we're passing around spreadsheets, people, to do, you know, build these advanced technology products in many cases. And it just creates sort of this perfect storm. And another thing that I noticed from my experience is every manufacturer's equipment set and process is different. Jeremy, have you experienced that? And, you know, I'd sort of like to hear from all of you because you've had experience at different places. Like, Jeremy, if you create a process that's working perfect for fabricator EMS company A, but you have multiple sources, sort of what does that do on your end?
It is that is a big problem. Like, everybody's different, you know. It even goes back to something I was thinking about earlier, is like the design rule check that all designers are familiar with in our tools. You know, I think there's that's part of the DFM. You know, Jerry brought up problems with aspect ratio and whatnot. If a designer doesn't sit down and just set up the DRC, design rule check, specifically for the person who's building it. I mean, because everybody's different. You know, fabricators A is going to be different from fabricator B. So you either got to build this board such that everybody can build it without a problem, you know, general capabilities, design rule check, or if you're getting into more complicated stuff like, you know, high-speed designs and impedance profiling and HDI. Now I've got to actually talk to Jerry and make sure that I'm setting my rules before I even start my design to match his capabilities. So that would help. But it does take time to get used to we need to talk to each other and make sure that we get to know each other to the level where I understand what Greg or Advanced Assembly would need to do the job properly. And that then when I talk to Jerry, I need to know what types of file formats does he prefer. His equipment might be different. And so I think it's pretty important to make sure that we understand each other and what each other needs, and that kind of is something that's missing, I suppose, is, we got to, well, maybe if you go online, a lot of engineers just want to stay in their silos and don't talk to anybody, I suppose, and just do their work. That might be the case, but we really do need to get in this environment where, we've got a designer and a fabricator and an assembly side of things all talking together and saying, what do you need? For the bill of materials aspect, something that I have to bring up, for Greg is, from point A, if I rip out a report for a bill of materials report, it's just a spreadsheet, which is ancient. And it's just a snapshot in time. And every minute that progresses from that point, that part might just disappear from the shelves. And so, for the most part, the way things are right now, I can develop a new board and send it to Greg and within a few hours, and he's going to be able to find and source everything. But a month from now, it's not going to be true. So, that's where like Active BOM and Altium Designer that's the thing that turned 90% hold rate to 10% hold rate on our supply issue was Active BOM. This concept of having all the components in your design right in front of you in Altium Designer, and it tells you the supply chain, what's available, what the cost of it is. So I can go through in there and actually do a BOM check. And that when I hit send to Advanced Assembly, I know with 100% confidence that they're going to be able to source everything on that BOM. Might not be true in 3 days, but at least it's true now. So that's where we have to get that Active BOM. That's got to be something that these guys get to see. They need to be able to interact with the way I get to see the design, which is, as things change, it resorts new part choices in there and chooses different components and puts them in there so that Greg could be like, oh, well, here's an alternate. I'll use that. So.
Yeah. And along those lines, if you sort of create your BOM in the beginning and then you're designing, they can age out that during your design process, and then you might go back and check it, right? These things are so volatile and moving all the time. It always amazes me. I want to say to our audience, if you haven't played with Active BOM, I would jump in there, because I think that is not to be sort of self-serving in this conversation, but I hear these conversations from people like Jeremy that it's really been a game changer for them. And I think it would help, people like Greg. So I'm going to ask you all a question. What I'm hearing you say is, a data package is just huge, right? And you sort of all have a stake in it, in that you got Jerry and Greg, you need to give feedback about capabilities back to Jeremy, but Jeremy needs to create a clean data package so you have as few, showstoppers as possible. So in your minds, who is responsible for a data package? I feel like I should throw the whistle and throw the yellow flag here, but go ahead, you guys, duke it out.
Jeremy's smelling the most. It's the end user. And the reason
and why do you say that?
Because they're the ones that understand the working environment. What does it have to perform to? What is an environment that it has to perform to? Is it sitting on a bench for an engineer to look at, or is it down in a hole well, drilling a hole, at the center of the earth? Is it going into space? Is it in a vacuum? Is it high altitude? Is it going to high moisture to low moisture in a matter of minutes? Is it a device that only lasts 3 minutes before, or 3 seconds before it blows up? We don't know. When somebody puts 2-ounce copper, we have no idea what the voltage is or the current it's carrying. We don't know. And so attending the reliability conferences, the IPC, is one of the guys, the first time I went, the guy said, we design and put in every single minimum or maximum in a design, and we never think about whether it's reliable. And it's true. Many designs are that way. We don't know what its requirements are, and they have to set the standards, whether it's class 2, class 3, space. We as fabricators don't know. We don't have no idea how much current is going through any conductor at any moment. As fabricators, we don't have that information. And so ultimately, the person who has the full understanding of all that is the person who's building the finished product, the end user. And they have to let us know, and it's actually documented in IPC 2221, 2222, and all the other ones, that they have to state what type of board it is, what class it is, what its performance is, and what its producibility is. It's technically, you're supposed to put these things on a drawing, so we know producibility C, it's the hardest, class 3, it has to perform the best. We know what we're building and why we have to meet those requirements. Another fun thing is many component manufacturers who are not on this panel will provide design guidelines, and they'll give them to Jeremy. He says, well, I'll follow this line, this drill size, this spacing. And in a LinkedIn post, I talked about a semiconductor's design guidelines, and I said, I use words like egregious when I responded back to their design guidelines they gave to the customers. It was something that was not based in reality at all. They were telling people to double track and put a conductor 5.5 mils away from a drill. But that's not even annular ring for class 3 in the same pad, but they're putting a conductor that's not the same net as a drill and saying 5.5 mils is fine, let's stay. It's not. And so there's a whole kind of a disconnect between the people making components, making design guidelines based on nothing other than what they think will get their product sold, I think sometimes. And they're not based on standards of the industry that IPC says they have. And then Jeremy and his team of people will go look at the data sheet, look at the design guidelines, follow it, and then they'll give it to us fabricators and say, nope, that can't be built.
Yeah, but then a data package is your responsibility too, because you have to let him know what your limits are as a manufacturer. So Greg, what do you say? Because I see you all have a stake in it. Greg, yeah, go ahead.
Yeah, at the end of the day, a PCB manufacturer is going to laminate, drill, plate, and mask boards and ship. An assembly house is going to put parts on boards. When you strip everything down, that's what it is. Both, the contract manufacturer, the fab house, and everything in between. Unless it's a truly custom and design house, everything is built to print. Okay, so it starts with the end user and ends with the end user. But there is so much skin in the game that I have, that Jerry has, that while it's in our hands, we have to be able to do. And so obviously there's design rules on the fab side. There's capabilities on the assembly side that are able to be done in-house, but, and it's our responsibility to communicate that back and forth to the customer. But at the end of the day, it's end functionality, to Jerry's point. I have no idea if this is going to be an actual prototype or if it's going into a live weapon. I have no idea. So we are going to be giving objective information based on what's presented in front of us, but not necessarily to what its final usage is going to be or anything like that. But I mean, as far as general documentation, going back to rev control, and all the requirements and all the pieces that are, as far as a deliverable, AS9102 fairs, certificates of conformance, and the whole 9 yards, that's all stuff that we owe as part of the assembly house. But anything really beyond that, we kind of close the loop back to the end user, and making sure that they got what they bought.
So for years, you guys, I want to hear from you, Jeremy, but for years, again, because I was sort of standing between you all, right? Trying to advocate and get you to align, both in person, email, phone calls. And it's quite an ordeal to get y'all aligned to make something reliable and great and on time and, you know, get it to market in a timely way. But I have said for years, I left industry for a short while and to raise kids. And when I came back, it was more disconnected than before I left. And I was sort of shocked by that. Like, what? Wait, what? I thought it would get better. But, you know, what I noticed is if you're 28 years old and you're an EE and you're laying out boards, chances are you've never been to a board shop. Last year, Lawrence, our MC here, just asked our audience, there's about 500 design engineers there, and he asked the audience, yeah, how many of you have ever been to your manufacturer's facility? And it was 10% or less. So that hurts. And I've been jumping up and down for years. One of the things I've done is blog and write. And I'm like, go to your board house, go to your assembly house, go to, the thing is these guys are slammed. It's like much like Jeremy. I'm like, I got my hands on mechanical tests, laying out the board, doing the schematic, running a design team, making sure my material matters. It's like they're slammed. So they don't have time, may not have a budget to travel to where they're. So, you know, this is why Altium is trying to lean into this issue. And really it's the reason behind the development of Altium 365, because the vision Altium has, which makes me so happy. I've said more than once that if I could be part of solving this problem, I would sweep the floors at Altium. And that is to design with manufacturing in real time, in the cloud. So there's full transparency, there's full speed. So, you know, my hope is as we develop Altium 365, that will help solve some of these things. So, Jeremy, who do you think is responsible for the data package?
Oh, yeah. Before I get that, even I want to follow up on what you just said. You know, we're all busy, and so traveling to a facility and being in person, I have to admit I've never actually been in person at a place like Summit. That'd be fantastic. And I'm also guilty of never picking up the phone. I love Zoom meetings and that sort of thing, but in today's world, it's getting better potentially. Like you said, maybe there is a lull for a while, but it's getting better because I gravitate towards people. So like when I'm picking who I want to work with, I tend to gravitate towards enthusiastic individuals, people that really get into, they love what they're doing. They're maybe doing webinars. So I consistently go to those fabricators and assembly houses that are putting on webinars, that are getting themselves out there in LinkedIn. They're just doing live shoots. I just watched one yesterday at somebody over in San Jose area. They're like, we're so excited about our new equipment. Take a look. And I watched their 10-minute video about their new equipment and the drill capabilities. And so I've seen a lot of these. So I'd encourage a lot of designers out there, if you're not out there in this wonderful LinkedIn world or at Altium's webinar site, watching these webinars, listening to people chat about this stuff and going, they can take you virtually into their facilities, and you should be doing this because it's super beneficial. I think it's awesome to see this stuff in action. As far as the data pack goes, you know, I think, you know, most people probably say the designer is probably one of the first guys in line to produce a quality, clean data pack, I suppose, and that may be true. I would put, you know, some of that responsibility lies in, we need to know what we're supposed to supply to you guys. So somehow we got to learn, you know, what does Summit need to produce this board reliably? And what are their capabilities, you know, and make sure I document it. And so from that perspective, I will say a habit that I like to do that is I'll literally just call up the engineers at the fabrication house and say, I want to do this. And maybe I want to fill, what do I have to put in the notes to make sure that I'm speaking your lingo? And so I'll just have them write the note, and then I'll put that note in the drawing. And again, it's designing the documentation, because like Greg said, they're building to print. So I have to make sure that everything in that print actually says what this thing's about. You know, it should have the performance class, it should have the producibility rating, so that they know what they have to inspect to, and it's pretty important. So yeah, I think it's important to just know that the fabrication house and the assembly house, I need to know who's doing it so I can ask them what they need. That's probably part of it. And I would also say Altium, in my case, is also responsible for a clean data pack, because their servers are holding all that data up in cyberspace. And so if it gets there all corrupt, I'm in trouble.
No, it's not our fault. Just kidding. Well, yeah. And whether it's cloud or on premise, I think it's our responsibility to make sure we're giving you the best tools. I want to move our conversation on now and talk about, here we are. We've covered all the disconnects, ways of maybe solving some of these problems, things you all need to know. But we're all working remote. We're in an unprecedented time. So I want to talk about the impact that all this remote working has had on each of you. And have you discovered any methods, tools, processes during this time that have helped you maybe plug some of these gaps, or maybe some advice you'd give to other design engineers that are watching this right now?
Yeah, I mean, I'll start. For us, back in March, we went remote, I believe, the last week of March, as far as most of our front office, engineering, sales support, basically anything other than production was all remote. And so it was a very, very rough learning curve for probably at least 4 to 6 weeks, where we were just trying and scrambling to try to, how do we communicate from the engineering and technical side of the business? How do we communicate from, the RFQ, the follow-up, the sales, the booking, order entry, all of these things, and turning that into a deliverable product, So I think for a lot of people, that initial shock to the system was just insanely difficult. And we even saw that even with our customers too, because we saw, just a disruption and change in the way that people were booking. People were reluctant to spend money. They didn't want to quote, let alone book anything. But, here we are going into the fourth quarter of this year, and I feel we are coming out of this stronger than I ever thought we would, because, we have applications like the format we're talking right now, where it's cool because I can meet face to face with you guys and have awesome conversations, still get things moving, still, and not have to wait for anything. I think it's helped us also figure out internally that we don't need to have a meeting for everything. We can either, send a quick note through email or a Slack channel or something like that. But we've had to just evolve very differently on how we communicate with each other internally, and then how we communicate with our customers, because ultimately they felt the same burden.
Jeremy, you had said some things when we were talking ahead of this presentation about some like transparency and humanity. You think that some of the Zoom meetings and things you're doing has actually improved. Can you tell us about that?
Well, yeah, I think it's hard to lie to somebody's face, but email is it's easy to get misconstrued or misunderstand, misinterpret, whatever word you want to use in emails and such. So I think like building the relationships having the Zoom format, we've always probably thought that it was a good idea to be having things like these Zoom meetings or any other video conferencing tool. But maybe there was a lot of people that didn't agree with it and wanted to live, in this 70s format that everybody should be in a cube in an office. And So when COVID came along and forced everybody home, it really, the silver lining there was it just forced everybody, even those that didn't really want to get familiar with these tools, give them a chance, and realize actually that it's just much easier and better to communicate in this form where I get to meet all of you three and everybody else that we get in here. It's just it just builds a better business relationship and friendship with the people that you're working with. So to me, it makes the whole idea. I enjoy working more than I think I ever have. After all these years, I just love my job. I love working with everybody and seeing everybody succeed together. So these Zoom meetings have been, and you know, just working in the cloud and at home or wherever, it's almost in some way brought people closer together. At least I've never gotten to meet people like Jerry and Greg face to face, but now here we sit. So you know, and Judy, man, we've spent a lot of time on Zoom. So there's a silver lining there for sure.
How about you, Jerry?
You know what, Greg, thanks for reflecting on what it was when during the startup, getting our IT guys going crazy trying to get everybody set up at home. That it was disruptive, and it took a while to get things in place. But as they started to work, you know, I'm so proud of what the telecommunication industry has done. That the bandwidth of the internet, the capabilities of getting us connected at home made this possible. If it was 20 years ago, the economy would have really taken a massive hit. But we're able to communicate real time, live, VPN into our servers, provide information to customers real time across the country, multiple time zones. And in the military world, during this time, it got busier. Our performance has been outstanding during this whole time. And you wouldn't have thought it would be the case. And because the infrastructure that has been put in place, been worked on for many decades, we're able to adapt, evolve, and make this thing work. What I found, and I thought for sure, we're just going to have wasted time. We're just going to make up meetings to keep ourselves busy at home. They were actually very focused on designs, getting stuff done, getting things fixed. And it really was amazed that these things were very focused because everybody was at home, not being interrupted by the coworkers going out to the cafeteria. They were focused at home and things got accomplished. And I noticed that after about a month, I go, man, these things are actually better than normal amongst many companies interfacing on a regular basis. So as far as business, I think that they're going to find out this is kind of a better way to get, and the quality of life was impactful. What ended up was we had more meals at home as a family. We'd have lunch together. We would sit there and have time, and then there was no commute home from work, so we sat down and had dinners together. We went for walks. In the time you commuted, you just did something else. Whether you were doing washing your clothes or doing things that gave you more spare time, free time, or you went for a walk and you enjoyed that, you found a way to use it, and it actually improved the quality of life as well as functioning business-wise. I think it's going to be impactful. I think the bottom line guys are going to realize this is a good idea. We don't have to buy real estate. We can just set this infrastructure, and we can monitor the performance of people because we're seeing it, and the bottom line is doing good. So hopefully we can find from this and learn from it.
Well, gentlemen, we're about out of time, but I want to thank you so much for this really rich conversation. Jeremy, I sort of wanted to wrap up with something you had said. You know, we have spent a bit of time on Zoom together, and one of the really great things I think you did, you really stepped up during this time, you know, speaking of connecting, is you started an Altium user group in Bozeman. So could you just take a minute and talk about that and your thoughts, you know, as far as the value of that went during this time?
Yeah, I think, well, it kind of goes along with the theme of what we're doing here, design with manufacturing, that we started, for the last 2 or 3 years, I've been kind of doing an Altium music group within Lumibird, you know, getting to know our French colleagues and Canadian friends and all this stuff. And And so it's about sharing what we learn. You know, if I talk to these guys here and learn something, right away I get to share with my group. You know, so we're just trying to make sure that we're not all learning the same mistakes. Instead, I'd rather, you know, like I say to my own son all the time, is it's better to learn from other people's mistakes than your own. You know, experience whenever you can, use other people's experiences and benefit from them. So, yeah, I think this idea of having a Montana user group and really pulling people together that are doing like things and sharing what we can about improving our designs and getting more excited about what we do, because a lot of us are, I think that we are doing some pretty amazing things out there these days, and it's fun and insightful. You know, it's really inspirational to be able to talk to your friends in your region or even within your own company, with the case of ours, and just say, what are you doing over there in France? What are you guys building? And it's pretty awesome. You know, the Altium 365 thing, that was perfect timing. As you know, it's like, so that was a tool that came along at a perfect moment in the whole COVID problem. And that forced us up into the cloud. And that's going to, I think, be a game changer for how we communicate, as far as like, you know, that concept of having your designs in the cloud, where Jerry and Greg get to interact with me directly with live comments. They get to see a live bill of materials. And that's a challenge to you too, Altium, is to finish that part choice and interaction that like Greg could have with the designer, where he gets to see my live bill of materials and see all the alternates I have listed on that bill of materials, and even comment on them and say, hey, can you approve these, and send out approval requests and things. So that, I think that getting out there in the cloud, you know, with COVID, we pushed that faster, you know, and went into that realm earlier. But I get to share things now with Jerry that I never had an option to do. You know, I can send him a design before I even submit it and say, can you comment on this? Are you going to be able to produce it? So, long-winded answer. I just like to ramble, I guess, but it's
and just to add to that, in using that software and looking at it, you go, you know, you have to make a note on your drawing because you're outside of a standard design and an A-bus condition now exists. So just make the statement so that we can both agree on the finished product of acceptability. Otherwise, we get a board and said, well, you know that this is going to happen. Are you okay with it? It's like, what do you mean something's going to happen? So it is really a powerful tool to be able to look at a design before it's done, before the rev spin, the $10,000 to $20,000 to roll a rev, to look at stuff and just ask some questions about it that we know affects, for us fabricators, what affects our fabrication. And then if we have experience and skills, things that we know that could cause Greg issues, like, you know, you probably don't want to have solder mask defined and edge defined in that large BGA because it's going to cause problems for the assembly guys. You might want to go to one or the other. So it will be a powerful tool. I think we're going to see a lot of benefit from it.
Yeah, it'd be nice to see what some of the parts that's invisible to me as a designer too is, you know, at what point do I have to start paying more money for this? You know, if I get my drill size smaller and smaller, at what point are you going to charge me more money for this trace width space? Everybody's different. So we're kind of going back to an earlier topic really, but you know, in some cases I've even seen the mask color change the price depending on who's building the board, you know, green versus blue versus red. You know, red may be higher performance than adhering to copper than blue. There's all kinds of weird things. So I'd like to have that commentary that we could have. You could say, you know, that's great, but it's going to cost you. You could actually make a couple subtle changes and save yourself some money and do the same thing. So we just got to be able to talk to each other in an easy format. And I think we're heading that way.
Well, I agree with you. And like I said, I'd sweep the floors at Altium or anywhere else that helps sort of solve these problems. And like I always say, everybody's innocent in some regards. Everybody in this sort of ecosystem we've all lived in, we're all, you know, working our tails off to make sure things are done right, get done reliably and all of that. And any ways that we could get more connected, more human, more accurate, in real time is great. So there definitely are some silver linings to this unfortunate season. So gentlemen, thank you again for joining us. I look forward to fielding some questions from our users in the audience. So thanks so much. And let's take some of those questions now. I wanted to mention here really quick that Jeremy and Jerry and some other colleagues of Greg has been on the podcast before. So if you had a chance to hear some of these conversations, I encourage you to go take a look at Altium's OnTrack podcast. So thanks again, guys. Let's go tackle some of the viewers' questions. Well, hi, Altium Live. Thank you so much for joining us. I hope you learned a lot from that panel or this panel. And I hope this rich conversation really helped you understand the disconnects. So we wanted to take a handful of your questions that came in during the session. So gentlemen, thanks again for a great conversation. Let's just dig right in. Jerry, this question is for you. A viewer said, what is the future of PCB from a manufacturer's perspective? What do you think we'll see in 10 to 20 years?
Wow. That's a good one. We're going to see the materials are able to handle the higher speeds of digital speeds, as well as the RF speeds. Our cars have detections. They can detect cars before you, behind you, and then they're working so that the cars can, Tesla's already has cars that keeps you in the right lane. You're supposed to be watching, you're driving, but these all work at like at 70 gigahertz frequencies. And so you're working at materials that are very high frequency materials. And these materials are difficult to work with for us fabricators. And so they're refining them, they're making them more standard for our processing. And we're finding out more and more of where the limits are on what the materials can withstand as far as drill diameters and plating and copper. We're discovering stuff that, because we have better test methods, that putting 2 or 3 mils of copper in a hole, oh, that's great. It draws heat from one side of the board to the other. It does. Except during lamination, as the material expands, that barrel is not elongating. We set our bass for tensile and elongation. And what happens is if you get too thick, it doesn't elongate. And with our testers and methods, we're saying there's a limit in how much copper you can put in a barrel without trading out for something else. We're getting smarter at what we identify the limits of our materials and what we can do. More and more microvias, more and more lamination strategies, and trying to get them built. It's going to be more costly and longer lead times for the amount of processes. Standard simple 1 lamination cycle board, 30 process steps. I had a customer design something, 595 process steps, and the yields were high. And then we looked at the design, changed it, and dropped it down to around probably less than 300. So talk to your manufacturers. They'll guide you in ways to build it cost effectively and reliable.
On the back end of that question, Jerry, someone else submitted a question here, and they're asking what new materials has made the biggest difference to fab capabilities in the last 2 years, would you say?
We're able to get low losses, like in the decays, like in the 3.1, and the loss tangents at I think Chubble 0, 6, and 5. So a lot of this was Teflon material. There's a lot of problems with Teflon. Things don't stick to it. Copper doesn't like to stick to it. Even when we put copper in a hole, it doesn't like to stick to it. We have to do special things to it. The stuff, we call it bubble gum because it stretches and distorts. So if we try to planarize it, we're distorting the GD and T on the material if it's a double-sided board. So a lot of material now is glass reinforced. They're mechanically spread glass, so we get consistent performance of diff pair or signal. No matter which way the track runs, the material is able to be processed like a normal printed circuit board easily and hit those high performances on the material. Lower, smoother copper, lower profile copper for insertion loss as the dielectrics get closer, that becomes an issue. So we're seeing more and more of that. And look at compliance in IPC 6012, that you're building stuff, and understand that if you go below a 3 mil dielectric, there's different rules that IPC says that board is now applied to. If you don't do it, then it has to be documented in the drawings.
Very good. Thank you. So, a new question just came in. Let me take a look. It says with Altium 365, if either the assembler or the fabricator suggests a change, would the customer typically ECO the design in their PDM to ensure the previous rev that it was reviewed is not built? In other words, rev control. Gentlemen, Jerry, I'm going to ask you this one because I know you have a lot of experience in this area. How do you keep the version control, if you are collaborating in real time, keep the version control updated?
So Jerry or Jeremy?
Sorry, Jeremy.
Okay.
They both sound the same.
Okay. Yeah, I guess in general, if there is a change that's going to make the package different, you have to change the revision. It's just a good design practice, good process control, because you can't ever have two instances of the same thing out there that can get mixed up. Yes, I guess you would have to make a new revision and share that with your manufacturer in any case, especially if it's required. If it changes any of the artwork or any of the drawings, any degree, it's going to need to be done.
Okay, so you do definitely flip the rev, even though you're sort of collaborating in real time.
Yeah, yes. My rule has always been if I've shared it with anybody, then I'm going to have to change the rev. And when you get into the production realm, you hope you don't have to do that very often because you've already ironed out all the wrinkles early on. So in the design side, when you're going prototyping and developing something, you can do this stuff pretty easily and quickly. There's not any tedious design release processes that slow things down. So you can move pretty quick. In Altium, it's super easy to just crank out a new revision and share it. It takes minutes, not days. So it's really easy, and it keeps everybody on the same page.
Great, thank you. The next question, Greg, I have is for you. Design engineer says, our EMS supplier handles everything. Sometimes they come back to me with, say, a fabrication question, but most of the time I don't even know who the fabricator is. And so that creates a little bit of a disconnect. And this person says sometimes they're not even allowed specifically to talk to the fabricator. So they're asking, how do I educate myself when I really don't have access? I may have access to you, Greg, but, as an EMS provider, if you're providing the fabrication services for your customer, how do you handle that? And how can this person get themselves educated and be a little bit more in the loop?
There's a lot. So if we're going to look at something from a turnkey approach, if something is booked with advanced assembly and we're handling the fab, we're handling the part procurement, we're handling the assembly and all the pieces that go along with it. Obviously, if there's general design rule violations on the fab side, those are going to be technical questions that are going to, put the assembly on hold, or put the fab on hold, and go back to the customer with, hey, look, what does this mean? I guess I'm a little concerned that there is no communication allowed from the customer to the fab house. That's a little interesting. It should be a transparent transaction on how you're doing these things. If there is a technical question that is for some reason above and beyond what our engineers can answer here, it's in our best interest to put our customer direct in contact with the engineers at the fabrication house. the customer knows their design best. They know their product, they know their end use best. It's in their best interest to be talking to the people that are going to be putting their hands on it and getting it to us so we can put parts on it. As far as getting educated, that's an easy question to answer, and it's a difficult question to answer. Obviously, if it's, kind of more of the, the PCB Fab 101 stuff, there's a lot of stuff on the internet you can look for. But at the end of the day, the higher level stuff, especially with HDI manufacturing, so on and so forth. I mean, these are things that take years of experience, years of hands-on, work with engineering teams, companies, and everything like that to really get your aptitude up to an appropriate level, I guess. But I mean, at the end of the day, I would really strongly urge this individual to make sure that they have adequate communication with the fab house. It's going to start with that, absolutely.
Okay, thank you.
Yeah.
I just call you guys, so.
Exactly.
There's a question here that's sort of aimed at Altium that I'd like to address, but it affects a few of us here. It says, now with the design rule documents and the possibility of exploring them, should manufacturers provide an Altium design rules document that we can import into Altium Designer to work with their minimum requirements? Wouldn't that be nice, you guys? I want to comment on that quickly. Don't quote me on this, or our developers. I think that's on the roadmap. Just that we can get to a point, particularly with Altium 365, that we could take in data from manufacturers, different manufacturers, that would give those, capabilities to be available in real time. Jerry, would you like that? Would you like to have those kind of guidelines available in a tool like 365 or Altium Designer?
It's complex. Even within our own DRCs and our own systems, we have over 1,000 different settings. And it's like crazy. How could you have 1,000 settings? 1/2 ounce, 1 ounce, 2 ounce, outer layer, inner layer, wrap plating, not wrap plating, class 2, class 3, and every one of these changes those rules. They have to be applied. So is it double wrap? Is it triple wrap? Are we doing wrap in the starting foil? And you start filling out all of these parameters. And then there's a lot of things that CAD designers look at in their systems as rules. They go, we don't care about that. Your legend, we don't care. As long as the track's 5 mils wide, not a problem. As long as the font sizes, that's in the eyes of the beholder. You're trying to make the board shop responsible for the height of the text. You picked it, you try to read it, it's up to you. My job is not to blob a B or a P into a blob. And if the silk screen goes over a pad, we just take the solder mask and clip it. And so, but this is not the first place that our CAD supplier that's talked to me, a fabricator. And somebody presented 50 different settings for legend.
Wow.
I'm like, I don't have time to set it up. And so in looking at this, I have 4 different board shops in Summit. Each one of us is different. And then you have to set all the settings for all the different copper weights, all the different outer plating, all the different wrap cycles, all the different class levels. And you're looking at thousands and thousands of settings for one factory. And then you got to set it for another factory, another factory. So it's, you probably should go look at IPC 2221, 2222 and set the guidelines in there. Because if you don't design to it, then you have to deal with it and contend with it. I'll give you a simple one, just a simple one. Copper pour for ESD on the edge of the board. Just pour it to the edge of the board. The IPC at 2221 says you're supposed to say a certain distance away and then add 2 mils for 0 to 50 volts and then another 2 mils as you step on the voltage. If you don't build to that rule, it's just one rule. Then haloing goes to an A-bus condition, which means if you put copper pour 6 mils away from my routing, I can halo all the way to the copper because it's just ground anyway. But you have to document that on a print. Otherwise, I'm going to stop and say, you have copper to the edge of the board. There could be haloing. If I have a board with haloing, are you going to accept it, yes or no? Before I start the build, tell me what the rule is. But you're supposed to know in the design, if you violated the rule. You're supposed to document it on the print, copper with halogens allowed. And so you would have to set all these settings for manufacturing, and all those manufacturers are different. All our board shops have different rules.
No, I think we should add that. I don't know if I'd want to just take design rules provided to me just as just the truth either. And it's not probably a good idea for designers just to accept these things and blindly throw them into their designs without understanding how these rules affect their design, how they affect the price tag of the end product they're making. You know, unless you put a little dial on there, you can turn up the price. You know, Jerry gives me a design rule check file that just says, how much are you willing to pay? You know, I don't know how that would work.
And for us, it's like every time they ask you a question, what's the smallest drill to copper distance? And it's like, well, that depends.
Well, I think, Jerry, what I keep thinking here, we're going to continue this conversation in Discord in a moment.
Okay.
So we're running out of time, and there's more questions about making sure we have a current BOM that I think Greg would like to address. So I want to go back to Eric Bogatin. It depends. I think that's what we're learning. And I think on the back end of Rick Hartley's presentation, where he actually has some slide decks talking about what is going to impact cost, you know, and when to push the limits and when not to push the limits. So let's go over to Discord and take on some more of these questions. Gentlemen, I appreciate your time, this panel, your expertise. It's been so fun to talk in this collaborative way with you, and I look forward to continuing this conversation.